The time was nearly 11 p.m. on June 20th, 2025, just south of the small community of Enderlin, North Dakota. Extremely warm and muggy conditions and a seasonably strong mid-level trough were present over a large portion of the region, with storms expected to be possible throughout the night. Just to the west of the small town of Enderlin, a powerful, fast-moving derecho was racing towards the town at nearly 80 miles per hour. However, another, more isolated threat was also bearing down on the small community. Just to the southwest of Enderlin, a potent supercell had fired over an hour prior and produced a strong EF5 tornado near the town of Fort Ransom. Now, nearly an hour later, the supercell had its sights set on Enderlin. As the powerful supercell continued to move closer and closer to Enderlin, it only continued to strengthen and take advantage of the exceptionally potent tornadic environment. In an instant, the supercell dropped a large, violent tornado just to the south of Enderlin. In just under 20 minutes, the exceptionally violent tornado devastated numerous homes, threw filled train cars like toys, killed 3 people, and became the first EF5 tornado to occur in over 12 years, snapping the longest streak without an EF5 tornado in history. Days before the 20th, forecasters were on high alert over the potential for an incredibly potent atmospheric environment over the Dakotas. A shortwave, mid-level ridge was forecasted to move into the upper Mississippi River Valley and remain over the region as mid-level heights increased, heating the surface and bringing extremely humid temperatures to much of the region. Additionally, beneath the ridge, a moist and unstable air mass was expected to be in place from the lower Mississippi Valley northeastward into the western Great Lakes region. Here, instability and deep layer shear appeared sufficient for a localized severe threat, though uncertainties remained on where the greatest potential for convection would be. Then, on June 18th, the SPC released a Day 3 outlook pertaining to the potential for severe weather on the 20th. This outlook was categorized as a slight 15% significant risk for all hazards throughout much of the north-central United States. In this discussion, the SPC noted the potential for isolated supercells capable of all hazards of severe weather along the extremely potent warm front in North Dakota. However, this threat was still highly conditional due to warm temperatures aloft that could stunt storm development. Instead, at this time, the SPC was more concerned with the potential of a powerful MCS or derecho forming in western North Dakota, causing a large swath of significant damaging winds and a few tornadoes over the nighttime hours. As for the overall system, a robust, mid-level trough was expected to move across the northern plains on June 20th, driving moderate upper-level divergence that would enhance lift and shear needed to initiate and maintain storms. This system was also anticipated to bring substantial convective available potential energy, or CAPE, to parts of the Dakotas and Minnesota, ranging from 3,000 to 4,000 joules per kilogram, paired with unusually strong winds aloft. CAPE, or convective available potential energy, is the instability in the atmosphere that is needed to produce potent supercells. Strong winds aloft are usually associated with higher potential for strong, long-lived supercells, which are the most common storm type that produces strong to violent tornadoes. In addition, a potent, nocturnal low-level jet was forecasted to develop after sunset, providing ample low-level wind shear to support significant tornado activity in the nighttime hours. The LLJ, or lower-level jet, commonly kicks in the late evening hours and can rapidly cause potent supercells to become much more conducive for tornadoes due to greatly increased low-level shear. These conditions combine to produce extremely high significant tornado parameters exceeding 10. However, many uncertainties still continue to remain about the extent of convection in the most favorable areas, as lift was limited and temperatures were projected to reach or exceed 14 degrees Celsius, potentially creating a warm nose that could suppress developing updrafts. However, the next day, on the 19th, the SPC outlook noted that a narrow zone of steep low-level lapse rates may foster a pocket of uncapped, highly unstable air, likely over northeastern South Dakota and southeastern North Dakota. If storms initiate in this region around or after 0Z, expect a heightened risk of very large hail and tornadoes. With this mention of higher potential for isolated storms, the SPC upgraded the tornado risk to 5% and the hail risk to 30% significant and the overall risk to enhanced. As the 20th grew closer, the potential for isolated supercells and thus significant tornadoes only continued to increase further. As the sun rose on the morning of the 20th, the atmosphere began to prime itself for a potentially significant severe weather day. In the morning hours of the 20th, the SPC upgraded the tornado risk to 10% significant for a large portion of central North Dakota. In this outlook, the SPC noted that tornadoes would be most likely with supercells and along the leading edge of bowing line segments. They also noted that a strong tornado or two would be possible in the region, and the more dominant supercells would be incapable of producing hailstones greater than 2 inches in diameter. Throughout the day, the 10% significant risk for tornadoes was maintained for the region, confirming the significant tornado potential. As the day went on, the environment continued to prime itself for tornadic production. The forecasted 14 degrees Celsius warm nose aloft that was supposed to potentially stunt supercell potential east of the main line was actually verifying lower than forecasted, with temperatures aloft in a small portion of the region ranging closer to 12 degrees Celsius. This underperformance of temperatures aloft had significant applications towards the severe weather potential for the day. With the lower temperatures aloft for the small region east of the bow echo, isolated supercells would be able to form in the incredibly potent region along the warm front and sustain for numerous hours, potentially forming strong to violent tornadoes in the process. As the day continued to go on, the SPC became increasingly concerned over the potential for significant tornadoes. Then, at 7:05 p.m. Central Time, the SPC issued the first mesoscale discussion pertaining to the severe weather potential in eastern North Dakota. In this discussion, the SPC noted the potential for scattered thunderstorms forming in southwest North Dakota that were expected to move east into eastern North Dakota through the evening. These storms would encounter a moist and buoyant air mass in southeastern North Dakota, with dew points in the upper 60s to lower 70s, fueling intensification. In the discussion, it was also noted that as the storms organized into a line, they would pose a widespread severe wind threat, with gusts potentially reaching 80 to 90 miles per hour. However, the discussion also noted that ahead of the main band, more isolated, discrete supercells appeared possible across southeastern North Dakota. These storms would form in a robust, low-level storm relative helicity within the warm frontal zone that would heighten the tornado risk for any supercells that developed. However, uncertainty persisted regarding the extent and timing of the convective activity further east due to a lingering cap and relatively weak forcing for ascent. Then, at 7:50 p.m. Central, the SPC issued a tornado watch for nearly all of eastern North Dakota. Around this time, a few elevated isolated supercells had fired near the small community of Spiritwood, North Dakota. As these storms continued to move in to the more favorable tornadic environment, they started to become surface-based. At 8:51 p.m., a strong EF5 tornado dropped just east of Spiritwood, damaging numerous homes and farms as it moved in a backwards C-shaped path. Although this tornado was significant, it was only the beginning. Around this time, the National Weather Service office in Bismarck, North Dakota launched a sounding to monitor the atmospheric conditions throughout the region. In this sounding, the extremely potent tornadic environment was confirmed, showcasing exceptionally violent parameter space capable of potentially violent tornadoes throughout the region. Around this time, the storms to the west of the original Spiritwood supercell were speeding to the east at nearly 80 miles per hour, causing extremely powerful straight-line wind gusts of over 100 miles per hour. However, even with the exceptionally powerful derecho out to the west, the National Weather Service offices had their sights set on another, potentially more dangerous issue. Just to the south of the Spiritwood supercell, another supercell began to fire in the potent environment. Then, at 10:17 p.m., a tornado touched down near the small town of Fort Ransom, causing EF2 level damage to multiple homes and a cluster of power poles. After producing this tornado, the storm underwent an extended cycling period over rural areas south of Highway 46. However, as the supercell closed in on the village of Liberty, North Dakota, the storm began to produce yet another tornado. Around this time, the derecho to the west of the supercell was only 20 miles away from the parent storm. The close proximity to the derecho heavily modified the near-storm environment and even further enhanced the low-level wind field needed to produce violent tornadoes. Then, at 11:02 p.m., a tornado touched down a mile south-southwest of Liberty, North Dakota, initially causing EF0 level tree damage to hardwood trees. As the tornado moved northeastward, it continued to expand and strengthen. The tornado then impacted the ADM Edible Bean Specialties grain elevator factory at EF2 level strength, snapping large trees and destroying an outbuilding. The tornado then began a violent, rapid intensification and widening phase as it turned northeastward. The tornado then peaked in intensity as it crossed a CPKC rail line southeast of Enderlin, derailing numerous train cars on a stopped freight train. Initially, the damage to the train near Enderlin, North Dakota went unrated because train cars are not a standard damage indicator on the EF scale. However, forensic evidence revealed the tornado's extreme violence at this site, prompting the National Weather Service and Grand Forks to conduct a thorough and unprecedented damage review. Here, the tornado had derailed 33 train cars, 19 of which were fully loaded grain hopper cars, each weighing up to 286,000 pounds, were toppled, with one dragged off the tracks into an adjacent field. The remaining 14 were empty tanker cars, weighing up to 72,000 pounds each. 4 of these cars were hurtled into a field, with one being thrown 600 to 1,000 feet and landing 475 feet from the tank car it was attached to. Notably, multiple wheel sets were detached at the points where cars were derailed. In collaboration with wind damage experts, the National Weather Service estimated winds of 230 miles per hour would have been needed to overturn a loaded grain car and over 266 miles per hour to throw a tank car 475 feet. This analysis led to an EF5 damage rating for the site, the first in over 12 years. Additionally, extreme radar measurements were recorded during the period of EF5 damage, and the train cars were lofted twice the EF5 threshold distance and were 4 times heavier than the heaviest objects in the reanalysis model. The tornado then began to turn north-northeastward, weakening to EF3 strength, but also growing to its peak width of over a mile wide. The tornado then blew over a cell tower that was anchored by 4 cables into the ground, completely scoured crop fields, and snapped large trees, debarking some of them. Here, the tornado also leveled an unoccupied farmhouse, shifted another house off its foundation, and damaged or destroyed outbuildings nearby. The tornado then began to narrow some, but became violent once again, moving along the Maple River and approaching North Dakota 46 at EF4 intensity. Here, an entire forest of trees along the river was leveled, with only the stubs of the trees left behind. Severe debarking of trees was also noted, with some of them being sandpapered, and some trees were lofted with the root ball attached, including one whose original location could not be determined. The tornado then crossed North Dakota 46 into Cass County and devastated 2 homes, with 2 deaths unfortunately occurring in this area. The first home, along with a well-built detached garage nearby, was obliterated and swept away with all the debris scattered downwind of both structures. It was acknowledged by survey teams that the tornado may have been stronger at this location, but insufficient anchoring prevented a higher rating than mid-range EF4. The second house, located approximately 300 yards to the west of the first along 140th Avenue Southeast, along with nearby outbuildings, was leveled. The tornado then crossed over the Maple River, leveling another swath of trees. All of the damage along the Maple River had previously been rated EF3 before later being upgraded to EF4 in the reanalysis. The tornado then weakened as it turned due north, paralleling 140th Avenue Southeast at EF2 strength, snapping trees and damaging crops, along with shattering the windows of a home and inflicting roof damage to a mobile home along 52nd Street Southeast. The tornado then incredibly turned north-northwestward and re-intensified to high-end EF3 strength, leveling another farmhouse and snapping numerous trees. Unfortunately, the third and final person was killed in this house. After snapping more trees and scouring additional crop fields at EF2 strength, the tornado then turned northwestward and toppled 4 tall steel electrical transmission towers at low-end EF3 strength. The tornado then quickly narrowed and weakened as it sharply looped back to the south, snapping some additional hardwood tree trunks at EF2 strength before dissipating at 11:21 p.m., approximately 5 miles southwest of Alice. In total, the violent tornado was on the ground for only 19 minutes, had a path length of 12.1 miles, and reached a peak width of 1.05 miles wide. According to the Enderlin Sheldon Fire Department, 10 homes had sustained some form of damage from the storm. Shortly after the dissipation of the EF5 Enderlin tornado, a second large tornado formed just east of the first tornado's path at 11:22 p.m. This second tornado caused EF2 level damage to trees and outbuildings across a 6.82-mile path before dissipating at 11:34 p.m. Governor of North Dakota, Kelly Armstrong, declared a statewide disaster following the tornado, activating the state's Emergency Operations Plan. On June 24th, over 150 volunteers joined in a joint cleanup operation in the areas impacted by the tornadoes. The International Red Cross and Red Crescent Movement also sent disaster teams to Enderlin to aid in recovery efforts. And volunteers from the Northern Plains UAS test site deployed an unmanned aerial system to help residents find personal items that have been lost as a result of the tornadoes. Very fortunately, the town of Enderlin was not affected by the tornado itself, although it lost power due to the storm. Debris from the tornado was found as far away as Moorhead, Minnesota, 40 miles from where the tornado had occurred. The tornado killed 3 people, all in the vicinity of Enderlin, making it the deadliest tornado to strike North Dakota since 1978, when an F4 tornado killed 5 people in Elgin. As for the scientific impact of the tornado, as mentioned earlier in the video, on October 6, 2025, the National Weather Service in Grand Forks, with assistance from several engineers including Timothy P. Marshall, upgraded the Enderlin tornado to EF5 level with winds over 210 miles per hour based on the lofting of several train cars and the tipping of 33 more. Researchers at the Northern Tornadoes Project in Canada also assisted the National Weather Service's Grand Forks office with calculating the estimated wind speeds required to lift and loft the train cars based on procedures established in a 2024 paper. The tornado also caused high-end damage to other areas, although construction limitations restricted the said damage points from being rated EF5. Additionally, the strong winds estimated to have caused the train damage correlated to the measured winds on the storm relative velocity data from KMVX. Melinda Behrens, meteorologist in charge of the National Weather Service office in Grand Forks, stated, "In the last kind of 12 years, there's been several strong tornadoes that have come close, but there haven't been known damage indicators at the time to support EF5 rating. It's hard sometimes to get tornadoes to hit something." Another interesting note on the tornado, the curved, inverted C path of the violent tornado strongly mimicked the path of the infamous Greensburg, Kansas EF5 tornado. In terms of the scientific impact of the Enderlin EF5 tornado, a new precedent has likely been set by the workers at National Weather Service Grand Forks and the researchers at the Northern Tornadoes Project in Canada. Accurately taking into account each damage indicator, whether on the predetermined scale or not, is vital to maintaining consistency and scientific accuracy in damage reanalyses. Using the uncategorized damage indicators provided by the Enderlin tornado, a new precedent has been set for violent tornadoes in the future, and potentially ones that have already been rated using the old system. One of the main fundamentals of science is to constantly drive innovation. Without it, science is practically useless. My hope is that this breakthrough can finally open the floodgates for new, more scientific tornado rating methods and calculations. Anyways, guys, thank you all so much for watching. I decided to go off on a little bit of a personal tangent about the tornado scale and all that kind of stuff near the end of the video to help portray kind of how I feel about this breakthrough and measuring the terrain, which isn't actually on the scale. I think it's a really good thing, and I hope that we continue to do that kind of stuff because it's really hard to get houses nowadays that are actually to the level of EF5 strength. So finding indicators like trains and other things, ground scouring and different things, and figuring out with physics how much wind speed it would take to actually cause that is really important. And I hope that that can continue to be utilized in reanalysis of tornadoes in the future. And also, I think to find some old tornadoes like Greenfield and a couple of these other tornadoes that have happened, Mayfield, and just be able to upgrade those if they need it. Obviously, if they don't need it, don't upgrade it. But you know what I mean. I definitely think it's a step in the right direction here. And this is kind of a groundbreaking tornado and really important, I think, to the tornadic measurement scale and everything like that. But I truly believe this tornado will directly aid in improving the tornado rating system and the new EF scale that's apparently in the process of being made. I've heard a little bit about that, but I don't know for sure. But anyways, I really appreciate you all so much for watching. I know I haven't made very many videos lately, but school's been pretty busy and swimming and stuff. But once I get into more breaks, I'll be making a lot more videos. But I really appreciate you all for sticking in. Don't forget to like and subscribe, and I'll see you in the next one. Goodbye.
directly in front of us.